is that we seek more understanding of a relationship than simply a correlation would tell us, right? So again, remember, if all we're interested in is correlations, we can estimate correlation coefficients, or we can simply estimate covariance. And that gives us a lot of information about the potential relationship between X and Y, or whatever variables we're describing. We are interested, though, in the causal mechanism. We're interested in the causal relationship between X and Y. Now, I have previously this semester used the term at length, and I want to bring that term back. And that term is the data generating process. Again, I will use directed acyclic graphs. So this is a directed acyclic graph that simply says that X causes changes in Y. That's what this says. X causes changes in Y. This does not mean that in the context of the data generating process that produces observed outcomes of Y. I want you to start thinking about variables, and specifically what will be our dependent variables. You want to start thinking about them not as a variable or even as a value. You want to think about them as the value of some outcome. So, for example, let's say that I was interested in measuring the relationship between education, years of education, and someone's wage. Right? That's an example we've been bringing back a lot. So in that context, a directed acyclic graph would simply be years of education causes wage, or just, yeah, wage. The title of this module, if you go to the syllabus, or if you go to the classes page, you'll notice that every module has a name. And if you're a keen observer, you might have noticed that every module has a name that is a reference to a song. Just What I Needed is a song, by one of my favorite bands, The Cars. And then this section we're in now, we call Good Vibrations, also a song by one of my favorite bands, the Beach Boys. The Beach Boys are a weird band because basically half of their stuff I can't stand, and then half of their stuff I think some of the greatest stuff ever. It's a weird band for me. But Good Vibrations. Okay, so why that terminology? Why in a section where ultimately I'm describing linear regression? What do I mean by good vibrations? From the book called The Book of Why. Which was written by Judea Pearl. Judea Pearl is one of the more important contemporary statisticians. A lot of what we know about statistical work, statistics is kind of like physics in a way. I mean, physics has been kind of dormant for a while. String theory didn't really work out the way a lot of people thought it was going to, and so physics has kind of been stagnant for a while, although there's been some recent findings and stuff that's lit a little bit of a fire. Statistics has been sort of the same way. It's been kind of the same for a while. There haven't been a lot of like big innovation, or there hadn't been, I should say, a lot of big innovations in statistics. And then Judea Pearl, who for the last like 25, 30 years, what he's been doing is he hasn't really been doing anything groundbreaking in terms of like, measurement statistics, like how we measure statistics. But what he's done that has been fairly groundbreaking is that he's sort of altered the way we think about the idea of causation. And the Book of Why, which I encourage everyone to read, especially those of you that are interested in doing analytics or doing any sort of research-based job, which most jobs these days are, especially if you have an economics degree. It's a book about causation. And really what it's a book about is how can we think about causation? And then what do we need in order to say something about causation? That's what the book of why is all about. And one of the things that Judea Pearl introduces in that book is this statistical method referred to as do calculus, which for your purposes doesn't really mean anything, but I just want to give it a name. And do calculus is a way for us to think about mostly conditional relationships. So something like, why, let's see, why, so that the value that y takes on is conditional on some value that x takes on, right? And when you say that the value that y takes on is conditional on some value that x takes on, you're using causal language. You're saying that the observed value of y is in some way dependent on the observed value of x. And by saying that, that is a causal statement. So we've already in this class talked about, conditional expectations, for example, right? The expected value of y with conditional on x being a particular value. So in some sense, this type of language should be a little bit comfortable to you. The idea that variables take on observed values because there are other variables that affect those values that take on specific values. So when x takes on a particular value, it influences the value that y takes on. It does not mean necessarily, and I think in some ways clearly does not mean that when x takes on a particular value, y takes on a particular value. That's not what we mean when we say conditional. What we mean is that there is an influence on y that occurs when x takes on particular values. And Judea Pearl refers to that influence as if you plucked a guitar string. So his idea is so imagine x and y are connected by a guitar string. You pluck the guitar at x, and then it vibrates and it influences, it affects y in some way. I think one of the things that happens when people use causal language, when they start using the word causality, is that, again, I said, it sounds too much like you're saying y takes on specific values when x takes on specific values. Now, there are things that, let's say, would have that particular relationship. For example, if, we were looking at, something that was affected by time, but was, let's say, unaffected by, any other sort of conditions. And then we could say time has a direct causal effect on that thing. But like, for example, even if we were, say, talking about grass growing, relative to time, and we could say that as time goes on, grass grows. But we know that the length that grass grows is going to be influenced by all sorts of other variables, not just time. So really, when we talk about causality, it's not that we're trying to understand what influences y the most or causes y the most. I think students get lost in that. We're just interested in the things that influence y. Oftentimes, we're interested in not just what influences y the most, but we're maybe influenced in anything that could potentially influence y. Like if we're talking about, cancer, for example, let's say y is cancer and x is some treatment, right? It's not that we are saying that the only thing that matters for cancer is this particular treatment. We're interested in the effect of that treatment on cancer. It certainly could be the case that there are a lot of other things that affect cancer in some way, right? So, like, let's say we're talking about your likelihood of getting cancer relative to you getting the HPV vaccine, right? One of the things that we've learned in the last 20 years is that, especially amongst men who get HPV, which is a very common thing to get, that there's an increased cancer risk. So we know that people, and especially men who get the human papilloma virus, have a slightly higher chance of cancer, right? There are a lot of other factors that also influence your risk of cancer, right? Familial genetics can influence your chance at cancer. I have on my mom's side, my dad's mom's side of the family, every single woman that's still alive has had breast cancer. And I'm talking like 6 women in one family, and every one of them has breast cancer. There's a lot of heart disease in my family as well, which that's great, man. Cancer and heart disease, that's definitely what you want to see. And even like my grandfather had Parkinson's disease, and they think there might be a genetic link to like Parkinson's. All of those things, other than simply getting the HPV vaccine, potentially influences whether somebody gets cancer. So, of course, we care, though, if the human papilloma vaccine reduces your chances of cancer, right? Because we would care about anything that would reduce your chance of cancer. So when we talk about causality, it's not that we're trying to figure out the main thing that influences why. I mean, that can be our point of analysis, but that's kind of a different thing. That's something we might refer to as model fitting versus causal inference. Now, as I go through some stuff, what I'll do is I'll talk about what would differentiate model fitting from causal inference, and what sort of choice differences would you expect if those two things were the goal, or one of those two things was the goal. Model fitting versus causal inference. You can do both of these things with linear regression. But I love the visual of the guitar string vibration. When I read that in the book, I was like, that's the way I'm going to describe causality for the rest of my life. It's such a beautiful way to describe it. And I think that as those of us, economists who were trained, I was largely trained in causal inference. That's mostly what economists are trained in these days. That's certainly the way that I came to kind of see what we do as economists, is that we're trying to uncover all of the causality out there. And all that is just information seeking. We're just trying to learn more about the world around us. And one of the ways that we can learn more about the world around us is we can perform causal analysis. I mean, just by virtue of the fact that there's so much focus on causal inference now, and not just in academia. I think I read recently that Amazon employs something like close to 200 economists. Why do you think Amazon hired 200 economists, most of them with PhDs that specialized in causal inference? It's because, can you imagine how many questions Amazon would like answered about causality? Right? Everything from seasonal influences on consumer decisions to picture decisions, the way the pictures look. Amazon does analysis on, like, when you look at an Amazon page, where do your eyes go? What's the causal effect of where your eyes go relative to whether you buy something? The reason why economics has ascended to be such a well-respected discipline is because we were one of the few disciplines that sort of said, yeah, we think causal inference is possible. And everybody else was like, no, you can't do that. That's causal. Even the statisticians were like, you can't do that. And then enough people worked on it that we feel pretty good about it nowadays. And now the rest of the world's coming our way. The rest of the world's like, oh shit, and then they just complain because then all the jobs are being taken by economists. This is the way it works. So Now, again, let's not lose sight of what we are doing. When we talk about causality, or even when we're talking about correlation, but certainly when we're talking about causality, in the context of linear regression, we're talking about a linear relationship. It's really important to never forget that when you run a linear regression, you're estimating a linear relationship. Okay, now there's two reasons why that's important. One, it's important because surprisingly, a lot of things out there have linear relationships. A lot of things have linear relationships. So that's one reason why it's good, or in some sense useful. The other reason why it's useful is because from an analytics perspective, from a mathematical perspective, it keeps things simple. It's a lot easier to do linear approximation than nonlinear approximation. Now, what's interesting about that, though, is that regression analysis can easily accommodate nonlinear relationships. And that becomes an important part of what we do is nonlinear relationships. So that starts getting us into an important conversation about functional form of the assumed relationship. Okay, we will, when we run linear regressions, unless we do something to deal with a nonlinearity, we're going to be implicitly assuming that the underlying relationship being measured is linear. Okay, now what we're interested in is knowing is that an appropriate representation of that relationship? Is the simple linear relationship the appropriate relationship for those particular variables? So what we end up doing is we estimate a linear relationship, and then we run a bunch of diagnostics afterwards. And those diagnostics tell us how much we should trust our results or how much we should not trust our results. And then based upon the results of the diagnostics, we do things, and then we run more diagnostics, and we just keep going back, right? If anybody ever, now it's probably not many of you, but especially just because the way cars are made nowadays. Has anybody ever worked on a car? Like often, yeah, like one of the things you do when you work on a car is you like work on it, and then you go start it up and you listen to it and you see how it sounds. And okay, is that the way I want it to sound? You know, if something doesn't seem right, you keep working on it. Then you turn it off, you go back to working on it, and then later you turn it back on. That's what that's what regression analysis is. You don't just run one regression and then that's it, I'm done. You run a regression, you test to make sure everything is kosher, and then whether or not things are kosher, you may still do other things, even if you think everything's fine, just to kind of put your analysis up to additional rigor. Okay, and that was one of the things I did at the very tail end of the video that I posted. Was we ran a regression, we found evidence of heteroscedasticity, and then we dealt with it.